Hello, my name is Jon Lindholm, and in this video I'm presenting my master's thesis regarding the topic Value Creation through a Building Lifecycle Service Model. The thesis was carried out for the Aalto University's School of Engineering as well as the construction company Fira Group. The thesis was supervised by Dr. Seppo Junnila and Niko Vironen from Fira and Laura Leinikka from Aalto University acted as the advisors. So in this presentation I'm going to go through a little bit of background of the study, then I'll go through the research objectives, research questions and the methods, and then we will move on to the essential results and discuss a little bit of the results. So to sum up the background of the thesis very shortly, during a building's life cycle there serves a large number of actors and even a larger number of information. And currently the value creation for the end users of the buildings is being hindered by different operational interfaces between these actors. And to solve this problem, utilizing building information models during the life cycle phase of the building is now being piloted in different projects to try to accelerate the different life cycle processes and the flow of information. And one of these development projects acted as the case project for my master's thesis. It's a project by Fira, Kojamaa, and Lassila and Tikanoja, and it had the following use cases for the BIMs. Attaching required handover documentation to the BIM objects, linking maintenance requests into the BIM of the building, and visualizing temperature and humidity information of the building in the BIM. So as the objective of the thesis, it was for me to identify how the service concept, which was in development, can create value for the maintenance organization which operates during the building life cycle. And this was to be achieved by answering the research questions: what requirements does the maintenance set for the building life cycle information? What information do they need and when do they need it? And secondly, how can the building information model undertake these requirements in a value-creating approach for the maintenance company? So the research was structured in the following way. A literature review was carried out in order to form the theoretical basis for the whole study and also to create the basis for the following interviews. The concepts of service business and especially customer value and value creation were defined. Regarding lifecycle information, the contents of maintenance manual and especially the contents and formulation of building information model were gone through. And regarding the lifecycle operations, real estate management, and especially the operational processes of real estate maintenance were studied. And according to the literature review, there was arranged expert interviews, and also I participated in workshops related to the case project. And together with the literature review, the interviews were used to answer the first research question of what information and when is it needed during the life cycle. And after presenting the case project, there was concluded the value created by the three use cases of the conceptual service model according to the theory and also according to the expert interviews. And before I move on to the results of the study, let's go through a couple of key concepts according to the literature review. Customers' perceived value is defined as a subjective trade-off regarding what the customer gives and what they gain. And in value creation, value is created when the customer's perceived trade-off is positive and the value creation only occurs in the end user's processes. As in the case project, they will study value creation related to a company. The core ideas of value creation in lean philosophy were gone through. The lean philosophy forms from the following steps: recognizing the required value of the end users, eliminating waste along the offering's value chain, and providing the offering for the end users when they need it. And regarding the building maintenance operations, it's essential to understand that above anything else, they intend to maintain a certain agreed on state and condition for the building. So let's move on to the recognized value of the different service entireties. Firstly, displaying handover documentation through the BIM. Currently, the caretakers mostly need built-in product information, and these different kind of documents, they are stored in cloud storages such as Tampuri in the case project. Generally, the caretakers, they don't trust these databases to be up to date, and they rather make phone calls and visits on the spot to gain this product information. And also these information databases, they vary between different buildings and owners, and they have very sluggish search methods. And the recognized waste of lean philosophy here is unnecessary motion. And as the benefits of the service concept, there can be listed that it's an alternative method for finding product information, either through the 3D geometry of BIM or through enhanced search methods enabled by the classified nature of the information in BIM. For the maintenance organization, it reduces the time it takes for a caretaker to complete service requests by reducing unnecessary visits on the spot and the amount of phone calls. It also provides more efficient search methods for information. And for the end user, it creates value by decreasing downtimes in the building. So the object-specific maintenance tasks in BIM, they are related to managing the caretaker's operations with more accurate task commissions. Currently, the specificity of the task commission depends on the end user's ability to describe the fault. If the caretaker wants further details, they either reach out to the end user or they determine the fault on the spot by themselves. Visits on the spot are carried out to determine the fault itself, the exact location of the fault, or required expertise, tools, or spare parts to remove the fault. Currently, the accuracy of the maintenance history is apartment level at best, and here the recognized waste is also unnecessary motion. So the benefits the service concept brings here are elaborating the fault as accurately and as early as possible in the fault removal process. It also enables more accurate historic data of the maintenance tasks, meaning object level in BIM. And for the maintenance organization, it can reduce the unnecessary visits on the spot, because what should be fixed, who should fix it, and how it should be fixed can be answered quicker. And through viewing the overall system, the fault removal process can be better planned ahead. And through object-specific maintenance data, solution descriptions for caretakers and also reports towards the owner can be more accurate. And for the end users, this shows as lessened amount of maintenance visits in the building, decreased downtimes, and longer functioning spaces. And finally, visualizing the indoor conditions in BIM. As mentioned earlier, the essence of the building maintenance is to uphold a certain state and conditions in the building. However, currently the quality of the maintenance service is assessed mostly by observing how well the maintenance hits predefined schedules in the calendar. In the figure below there is presented the two most common ways to initiate a maintenance task. In the first one, a tenant service request initiates the process, but the problem there is a long downtime. In the second one, the service provider's ERP's calendar initiates a task. Even though the downtime is shorter, there occurs a waste of overproduction. And in the third one, there are sensors which indicate changing conditions in the building, and the maintenance task is initiated automatically according to the sensors. And now the waste of overproduction is eliminated. This is related to a future vision for the maintenance called predictive maintenance. For the maintenance organization, visualizing indoor conditions in BIM is especially important in directing the development of its future operations towards predictive maintenance. And for the end users, it can decrease the downtimes in the building, and value is actualized the more accurately there can be carried out predictive maintenance. And finally, as some things to consider regarding the results is that connecting systems and databases into BIM requires a lot of integrations, and currently there's debated what is the best solution for this. In the case project, the solution was utilizing an open platform to enable these integrations. Also, for the service model to be as scalable as possible, some standardization of the BIM formulation may be necessary, as currently their contents are dependent only on what there's agreed upon in the contracts. Regarding predictive maintenance, it proved to be very similar to the ideas of lean philosophy from the perspectives of customer value creation and development of companies' operational management. But applying predictive maintenance will require changes in the contract models of maintenance in the future. Also, realistically, not all scheduled tasks can be removed and replaced with predictive maintenance. For example, tasks which require expensive equipment or machinery will probably still be more cost-effective to be carried out in bulks in the future. Also, predictive maintenance is highly dependent on what is agreed to be observed through the sensor data and on the logic and automation used in the integrator systems to detect failures. All in all, shifting the operational management of the real estate maintenance towards predictive processes seems to enable for them to better utilize their expertise during the building life cycle. And finally, I want to thank Aalto University and Fira Group for letting me do this thesis from this interesting topic, and also thank you for watching.